welcome to the VTV channel. So we'll go with the second topic in aptitude, that is LCM and HCF. First see that what is the meaning of LCM. See, LCM deals with the least common multiple. It deals with the least common multiples. Those terminology is related to the LCM. Same thing, HCF. The HCF is deals with the highest common factor. So this is the meanings of LCM and HCF. See, the other name of HCF. HCF is also called as GCM or GCD. It means greatest common either measure or divisor. So greatest common divisor or greatest common measure is also other form of HCF. Okay, first see, LCM deals with the multiple of a number. HCF deals with the factor. Factors means the divisible of given numbers is a HCF. Okay, first we will go to example. Find the LCM of 6 and 8. So that is the first example. First see, pick a first number 6. So first of all, LCM means least common multiples, means you can pick a multiples of 6. Multiples of 6 means 6, 12, 18, 24, 30, 36, 42, 48, so on. These are the multiples of 6. In the same way, take it as other number 8 and consider as a multiples. Multiples of 8 means 8, 16, 24, 32, 40, 48, 56, so on. These are the multiples of these two numbers. So out of these two multiples, consider common. First pick a common. So common part of 6 is 24, 8 is a 24. Other number 48. Other number 48. If you want next number means the difference of every 24 numbers is a common multiples of 6 and 8. Means those numbers are 24, 48, 72, 96. So on, these all the numbers are common multiples of 6 and 8. So out of these numbers, we need to pick a least one. So least means out of 24, 48, 72, 96, whatever the numbers, the 24 can be defined as least multiple number of all these one. It means the LCM of 6 and 8. The LCM of 6 and 8 is equal to 24. That is the first part. So this is the basic approach. If you want to go with the HCF means find the HCF of 30 and 45. This is the HCF. Same thing. Factors of numbers. Factors means the divisibles of 30. 30 is divisible for 1, 2, 3, 5, 6, and we'll go with the 15 and 30. These are the exact divisibles of 30. If you go with the 45, 45 can be divisible by 1 and it can be divisible 3, it can be divisible 5, it can be divisible 9, 15 and 45. So these are the factors of 30 and 45. Out of all these numbers, we need to pick a first common part. Why? Because HCF deals with the highest common factor. Pick a common things. The common parts are 1, 3, 5, 15. These are the common numbers. 1, 3, 5 and 15. So we are picking as a common things. So out of all the common things, we need to pick a highest number. See, the highest number of all these parameters is equal to 15. It means the HCF of 13 and 45 exactly equal to 15. So this is the definitions of LCM and HCF. Remember that HCF other form can be defined as greatest common measure or greatest common divisor. Clear? See next one. If you take one example 6 and 8. So find the LCM and HCF of these numbers. So this is the approach number 1. Okay, first of all see, we know that 6 and 8, the common multiple of 6 and 8, that is exactly equal to 24. And we have a direct approach. See, the LCM is always depends on highest number multiple. So the LCM is always depends on the highest number multiple only. Means out of 6 and 8, out of 6 and 8, 8 be the highest number. So take it as highest number multiple. So 8 1 is 8, 6 is not divisible, 8 2 is 16, not divisible, 8 3 is 24. So those 24 is exactly divisible by 6 and 8. So if you want to LCM means pick a highest number. Out of highest number, that multiple can be decided the least common multiple of those two numbers. Same thing. If you want to go with the HCF, see, HCF can be depends on lowest number divisions. The lowest number divisions can decided as HCF. In the main, see, out of these two numbers, pick a lowest number 6. So 6 can be divided exactly which numbers? 6, 3, 2, 1. These are the 4 numbers exactly divisible by 6. Then see, 6 is 8, not divisible. 8, 3, not divisible. And 8 is exactly divisible by 2. Means the first number can be considered as highest number. It means 6 and 8. 6 and 8, the HCF can be defined as 2 only. So the direct approach we can say is that LCM can be defined as highest number multiple and HCF can be decided as lowest number divisible. Whatever that lowest numbers that can be decided as HCF. Okay, if you go with the other form, see, there are two approaches for solving LCM and HCF. The first approach is prime factorization approach. The prime factorization approach, and second one, that is division approach. So I just take these examples. See, so prime factor approach for LCM, for HCF. I just go with the example. See, if you consider as a 6 and 8, so 6 can be considered into prime factors, means those number is 2 and 3. In the same thing, 8 can be considered, the value become 2 cube. We know that if you want LCM and HCF, we required as a common multiple, common. See, 2 and 3, 2 cube. So here 2 is a common. Out of 2, we have considered as highest power, 2 cube. And we think that, sir, there is a no common for 3. It means we cannot consider. See, if there is a no common number, these factor can I write in terms of 3 power 0. Why? Because 3 power 0 be the value become 1. Then see, here 3 power 1, here 3 power 0. We can pick it as the value become 3 power 1. Means the 2 cube is equal to 8, 3 power 1 is equal to 3, 8 3s are 24. It means the prime factorization consisting of LCM as consider highest power and it does not require common numbers. It does not require any common numbers for consider of LCM. Why? Because if you pick it as any highest number, the other value become 3 power 0, 3 power 0 or a power 0. Any number power 0 always become a 1. But that's why it does not consider any common number. So directly you can pick a numbers and consider highest power. If you want HCF, means HCF you can consider as lowest power. Consider as lowest power, and definitely we required common number. Definitely we required common number. See, if 2 power 1, 3 power 1, 2 cube and 3, so out of 2 we have a common 2 power 1, 2 cube, we just consider as a minimum power, that is 2 power 1. So if you consider as this is not a value, see, if 3 power 1 is there, 3 power 0 is not there. Clear? Out of these calculation, there is a no common for 3. If there is a no common for 3, it does not consider in terms of HCF. That's why directly you can consider 2 power 1 value be the HCF. That's why the LCM deals with the highest power. It does not require any common number. If you want to go with the HCF, definitely we required common number. If it is a common number, you can pick those numbers. Otherwise, don't consider those numbers. So this is the approach for prime factorization. Clear? If you go with the division approach means, for example, 6 and 8. For 6 and 8, what are the number exactly cancel? 2 become 3 times and 4 times. And 3, 4 is does not cancel in any particular number. Means we need to multiply these numbers. We get the division of LCM. See, if two numbers are given, simply the cancellation of exact term. See, 2 how many times? 3 times, 2 4 times. Multiply all these numbers. We get the LCM of these answer. If you want HCF means, the HCF means, first of all, see division approach. Here 6, here 8. 6 become 8, we have only one time. We get the resultant is 2. Again see, now remainder become a dividend and the dividend become a divisor. So those value become here 6. Clear? And 2 become a 6, exactly 3 times. We get a 0 as remainder. If any cancellation has 0 as a remainder, the previous dividend, whatever the dividend value, it is always be the HCF of given numbers. Clear? Okay, I will go to one more example. For example, see 10, 12, 15. Find the LCM and HCF. Clear? So I just go with the division approach. See here, if you go with the division approach, first 10, 12, 15, there is no common number. So directly you just go with LCM. So LCM is depends on highest number. So out of all these number, this is the highest number. So it can be decided only LCM. If you want HCF means the lowest number can decided as the HCF. See, if you want LCM means here we have a 15. Consider as a 15 multiple, 15, 30, 45, 60 and these all the numbers. Then see, 15 is not cancelled in terms of tens. 30 is cancelled but 12 is not cancelled, that's why again it is eliminated. 45 is not divisible by 12, again eliminated. And 60 be the common multiples of 10, 12, 15. 10 6 are, 12 5 are, 15 4 are. In the same way, if you want HCF means out of all these numbers, you can pick a lowest, that is 10. The factors of 10, see, the factors of 10 means 1, 2, 5, 10. Then see, 10, 1, exactly divisible, 12 divisible, 15 divisible. So 10 is there is a chances. So 2 divisible, 2, 12 is divisible, but 2 is not divisible by 15. And the next number, see, if you go with the 5, so 5 2s are, 5 3s are, 12 is not divisible. Again 10 is not divisible. So out of all these numbers, these all numbers are not divisible. Means the HCF of 10, 12, 15 is exactly equal to 1 only. Clear? See, simply if we require LCM, pick it as a highest number multiple. If we want a HCF means pick a lowest number factor. The factor can define as a highest divisible number. Clear? See, find the LCM and HCF in prime factorization concept. See, I clearly mentioned earlier, the LCM does not require any common number. If we want HCM means definitely we require common number. See, if you want to go with the LCM of all these numbers, see, out of 2, we can pick a highest power. Just pick a highest power of 2. So out of all these numbers, the highest power is equal to 3. Next one, if you consider as a 3, here 3 be the common, you can pick a highest power, that is 3 cube. In the same way, out of 5, 5 square, 5 cube, you can pick a highest power, that is 5 cube. And here 7 square, 7 power 4, 7 can decided highest power is 7 power 4. Then we have a doubt, sir, 11 is not there. I clearly mentioned that if it is required LCM, we does not require any common number. Why? Because, so we can replace us here by the 11 power 0 and 11 power 0. Why? Because 11 power 0 value is a 1. So in this particular resultant, the total value is does not changes. That's why if you want LCM means don't focus on the common number. Why? Why? Because whatever the number it can decided as LCM. That's why 11 is also considered for LCM. Same thing. If you want HCF means we required as a common number and you can pick a lowest power. So whatever the prime factors you just consider as lowest powers. See, so 2 will be the lowest power, 3 be the lowest power, 5 be the lowest power, and 7 be the lowest power, and 11. So 11 is not considered. Why? Because in the given question there is a no common number. If you want to go with this some number here, so 11 power 0, 11 power 0 we can replace this. So out of 11 power 0, 11 power 1, we can take it as 11 power 0 be the lowest power. That's why the HCF always required as a common number. That's why the answer is equal to 2 into 3 into 5 into 7. This is the concept of prime factorization. If it is a LCM, we does not require any common number. If it is a HCF, definitely we require common number. So LCM in the prime factorization you can consider as highest power. If it is HCF, you just consider as lowest power. See, the division approach for LCM and HCF. See, if you want LCM means out of all these numbers, we just go with a common thing. What are the common thing? 12, 15, 27 is exactly a multiples of 3. So I just go with a 3 here. 3 4s are 12, 3 5s are 20 be the common. Again 3 9s are 27. Again if you go with the multiples of 5, see 4 be the common, 5 1s are 5, 5 4s are, and 9 be the common. If you go with again 4 here, we get a 1, 1, 1 and 9 be the common. So whatever the remaining numbers, 3 into 5 into 4 into 9, it decided the LCM least common multiples of these all numbers. See, so 9 4s are, see 9 4s are 36, 5 3s are 15. If any number which is multiple with a 15 means 36 10s are 360. Again, so 15 can be considered as 10 plus 5. So 5 is the half of the 10 resultant. It means 36 10s are 360. 36 5s are means 360 of exactly equal to 180. If we add all these numbers, it says 0. 8 plus 6 14, 540. So the LCM can be decided as of these number is 540. If you want to go with the direct pattern, see, out of all these numbers, it can decided, see, these can decided as the LCM of all the numbers. First pick, so 27. If any number which is divisible by 20, definitely we require units place as a 0. That's why you just consider directly 27 into 10, 270. But 270 is not divisible by 12th table. That's why you just double it this number. 270 double it number exactly equal to 540. This is the first common multiples of exact 12, 15, 20 and 27. This is the division approach. In the same way, find the HCF of 3 numbers. See, if you want division approach means you can pick any two numbers. Any two numbers you can pick. So I just pick a 1134, 1215. So 1 times exactly equal to 1134. Here we can go with a 1. 11 minus 3. 11 minus 3 is equal to 8. So here we get a 81. Now the remainder become a dividend and dividend become a divisor. So this is the value of 1134. Again see. So I just go with the 81 ones are 81. If you subtracted these values, see 3 minus 1 2, 11 minus 8 30. So 334. Clear? Again see, if it is a 324, definitely this is absolutely for 14 times. So 81 4s are exactly 1134. We get the resultant is 0. If we get 0 as a resultant, the previous number is highest common factor for 1134 and 1215. See, so we just calculated the highest common factor of these two numbers is equal to 81. Then the same approach you can apply for 81 and 513. See, 81, 513. So, absolutely 81 6er. See, 81 6er, 8 6er, 48, 486. 486. If you go with the resultant, the value become 27. Now, it is a dividend and it is a divisor part. So, 27 3s are 81. We get the resultant is 0. It means the HCF of all these numbers, for answer is equal to 27. So this is the division approach. See, if you want to go with the factorization approach, LCM does not require any common number. You just consider as highest power. If it is a HCF, you can pick a lowest number and consider the factors, and those highest number can decide it as a HCF. If you want to go with the prime factorization approach, you just go with a lowest power and it required a common number. It does not require a common number, but it required as a common number. If fraction is given, see, A by B, C by D, E by F. These are the fraction of given numbers. If fraction is given, we need to find the LCM. If we want LCM of the fraction means the LCM of numerator values like a ACE divisible by HCF of denominator value, that is B, D and F. In the same question, find the HCF of above fraction. The HCF of above fraction can define as HCF of numerator values ACE divisible by LCM of B, D, F. This is the formula. Okay, if you want an example, see, find the LCM and HCF of given numbers. I just consider as 2 by 3, 8 by 9, 16 by 81, 10 by 27. See, this is the example. Find the LCM and HCF of all these numbers. See, if you want LCM means consider as LCM of all the numerator number. I clearly mentioned that the highest number can decided exactly a LCM of numbers. See, 16 multiple can decided as a LCF of given number. So 16 multiple, 16 ones are 16, 32 is 10 is not divisible. If any number is divisible by 10, we require 0 as a units place. 16 5s are 80. This is the number for exactly divisible by 10, 16 and 8 and 2. So the numerator section is 80. If you want HCF means see 3, 9, 81, 27. Out of all these numbers, the lowest number can decided as HCF of all these numbers. See, the factors of 3 and 1 only. But 3 is the common the exact divisible of all these numbers. 3 is divisible, 9 divisible, 81 divisible, and 27 divisible. That's why the answer of this question is equal to 80 divisible by 3. In the same way, find the HCF means. If you want HCF means, find that. Focus on HCF of all these numbers. See, 2, 8, 16, 10. HCF can decide it as lowest number, and 2 is the exactly divisible of all these numbers. That's why the HCF of numerator is equal to 2. If you want LCM means 3, 9, 81, 27. The highest number can decide it as LCM. Then 81 is the common multiples of 3, 9, 81 and 27. Then answer is equal to 2 by 81. See, if fractions are given, if you want LCM means LCM of numerator by HCF of denominator. If you want HCF means HCF of numerator divisible by LCM of denominator. Okay, I just go with an example. Same, I just consider 6 and 8. We are already finding the LCM of 6 and 8 is equal to 24. Clear? And HCF of 6 and 8 exactly equal to 12. This is the example. See, 6 and 8. The 6 and 8 LCM is equal to 24. HCF of 2. See, if you multiple with 6 and 8, 6 and 8, 6 and 8 is 48. Same thing. If you multiply LCM and HCF, those resultant is also 48. It means the property says if product of two numbers, that is the rule, product of two numbers, if product of two numbers n1 into n2 exactly equal to LCM of those two numbers into HCF of those two numbers. So this is the first rule. See, if you consider as any two numbers, the product of those two numbers exactly equal to product of LCM into product of LCF. Then here resultant number 2. So second important point, the HCF, see, whatever the HCF, it is always divisible by given number. Whatever we are finding a one number, that is exactly divisible by HCF. This is the important property. If those number is exactly divisible by HCF, those numbers is always be the true. So here two properties. See, if any two numbers are given, if product of those two numbers can exactly equal to LCF of two numbers and HCF of two numbers, and whatever the two numbers, that is exactly divisible by HCF of given number. These number is exactly divisible by these two numbers. That is the important part. Let's see the example. See, if HCF of two numbers is 11 and their LCM is equal to 7700. If one number is 275, find the other number. That is the concept. See, I mentioned that if you consider as two numbers, those products and those product of numbers exactly equal to LCM of two numbers into HCF of two numbers. Those can be decided LCM of two numbers into HCF of two numbers. See, N1 into N2 means 275 is the one number. Other number I just consider as N2. And if you multiply product means 11 into 7700. See, if 11 become exactly 25 times. Again, if you cancel these numbers, 25 ones are 25, 25 threes are 75. We have a 200. 200 means that is absolutely for 08 times. Means the other number is equal to 308. See, if you go through the 308 is an option, first check it out. The number is always divisible by HCF of number. If it is exactly divisible, the number is true. Otherwise, that is a false. Then check it out. See, 308 divisible by 11. 11 ones are 11, 11 twos are 11 eights are. Means the other number absolutely for 308. In the same question, see, if LCM of two numbers is equal to 120 and HCF is 15, if one number is 45, find the other number. It means 45 into N2 exactly equal to 120 into 15. Again see, 15 become a 45 exactly 3 times. 3 become 40. Then N2 number become 40. Then see, we can choose 40 as answer. But I clearly mentioned that if you get a numbers, those numbers is always divisible by HCF. See, if HCF is 15, here one number is equal to 40. If 40 is not divisible by 15, means answer is can't be determined. For these resultant, we cannot determine the answer. See, if it is a numbers, those numbers is always divisible by HCF. That is the important property. Clear? See, if LCM of two numbers is 45 times the HCF of two numbers, means the ratio of LCM by HCF is exactly equal to 45 divisible by 1, means 45 is to 1. And if one number is equal to 125, find the other number. If sum of these two numbers exactly equal to 1150, see, if sum of two numbers means the numbers I just assume as 45x is a one number and other number is x. If you sum of these two numbers, the answer is equal to 46 exactly equal to 1150. Then 46 25s are 1150. Then x's value become 25. It means the LCM of one number is equal to 45 into 25 and other number is equal to 25. Here my question. Find the other number if one number is equal to 25. We know the rule. If product of two numbers exactly equal to LCM of two numbers into HCF of those two numbers. Then see, if one number is equal to 128, LCM means LCM number is equal to 25 into HCF means 45 into 25. And if one number is given already for 125, then see 25 5s are 25 5s are. Then finally we have 45 into 5. 5 5s are 25, 2 here. 5 4s are 20, 20 plus 2, 225. Then other number is related to 225. So this is the important property. If any product of two numbers exactly equal to LCM of two numbers into HCF of two numbers. Clear? See the other application. If you consider as a number 3, 4. Then LCM of these two numbers means 3 into 4. So 3 into 4, the resultant decided as LCM. If we want HCF, 3 and 4 is exactly divisible by 1 only. Means see, 3 and 4 means 3 into 1, 4 into 1. Okay, then see, if you want LCM means out of common number you can pick only 1. So that is 1. And remaining 2 are different numbers. That's why we should multiply 3 into 4 into 1. If you want HCF means whatever the common number in both the multiples, that we decided as HCF. Means here we will go with the one important concept. If HCF is given, we can find the LCM or any other application. For example, if HCF is given, as A, if you want two numbers, the two numbers means those two numbers I just consider as AX and AY. See, AX and AY, if you go with the highest common factor for AX and AY, that is a only. That's why if HCF is given, consider two numbers, those are AX and AY. Here the important application, X and Y can decided as co-prime numbers. So that is the important application. Again we have a doubt. What is the meaning of co-prime? I earlier mentioned that co-prime means if you consider as any two numbers, the highest common factor is 1. If highest common factor is 1, those concept is always related to co-prime. Means 1 is the only divisible of those two numbers. If 1 is the divisible of those two numbers, those we can call as a co-prime number. See, if HCF is given as A, if two numbers we consider AX and AY, then XY we just decided as a co-prime numbers. Then for example, if HCF is given, we can decide the numbers. If we want LCM means LCM of those two numbers AX and AY, the LCM can decided as AXY. For example, if HCF is given, we assume a number. If you want product of two numbers, the answer is equal to A square XY. If same thing, if HCF is given, we just assume two numbers. If we want sum of those two numbers, so sum of two numbers exactly equal to A into X plus Y. Clear? And if you want a difference of two numbers, the value become A into X minus Y. So you can go with any calculation. Just observe that if HCF is, you just identify, you can assume the number. If HCF is A, the two numbers are AX and AY, but definitely you can mention that X and Y can always satisfy the co-prime number concept. Clear? Okay, just see the question. If LCM of two numbers is equal to 28 and the ratio of their ratio is equal to 2:3, sum of two numbers is equal to how much? See, the ratio of two numbers is equal to 2:3 means those numbers are exactly 2x and 3x. First decided the numbers. Out of these two numbers, the LCM is given. LCM of 2x and 3x exactly equal to 2 into 3 into, you can pick up 1x means 6x exactly equal to 48. If 6x is equal to 48, 6 become how many times? Exactly for 8 times. So then x value become 8. Then more question. Find the sum of two numbers. Sum of two numbers means sum of two numbers is equal to 5x. So 5 8s are 40. Then option is equal to 40. Okay, if you go to the second question, see the ratio of two numbers is equal to 3:4 means 3x and 4x. He mentioned that HCF is 4. See 3x 4x, the HCF is exactly equal to x only. Then directly given x value exactly equal to 4. Then find the LCM of two numbers. See if 3x and 4x, the HCF is x. If you want LCM means 3 and 4 is a multiple with x only. The answer is equal to 12x. Then 12 4s are 48. Then option is equal to 48. See, sum of two numbers is equal to 528 and their LCF is 33. The number of pairs can satisfy the above condition. Clear? So this is the example. See, we don't have any information related for sum and HCF. So we have a reverse concept. If HCF is given, see, if HCF is given, we assume a numbers are 33x and 33y and x comma y is exactly equal to co-prime number concept. If sum of two numbers means 33 into x plus y exactly equal to 528. If you go with the cancellation, 33 ones are 33. So 33 ones are 33. We have a 178 and 33 6 are 178 means x plus y value exactly equal to 16. Then form a number of pairs. The number of pairs sum of 16 is equal to, I just go with a 1 comma 15. Next one 2 comma 14. Next one 3 comma 13. Clear? Why? Because sum of all these two numbers become a 16 we required. So next value 412, 511 and 610, 79 and next number 79 and 8. So these are the pairs. See 1 2 3 4 5 6 7 8. So total number we have 8 pairs. But 8 is not an answer. See why? Because that whatever the consider of pair always required as a co-prime number. Co-prime numbers means between two numbers the highest common factor is a 1. So 1 and 15. 1 is the exact. 2 14 the HCF is 2. You assume as 3 comma 13 as a co-prime. 4 12 is not a co-prime. 5 11 is a co-prime. And if it is even numbers, definitely those are not a co-prime numbers. Then again 7 and 9, 8 is not a co-prime number. So the total number of pairs satisfy these condition is exactly equal to 4 only. See, if product of two numbers is equal to 3000, if their HCF is 5, find the number of pairs exist in the above condition. See, same rule, if HCF is given, the numbers are 5x and 5y. And product of those two numbers are 25 xy exactly equal to 3000. See 3000, sorry. So 25 become how many times 25? 12s are 300, that is absolutely for 120. Then product of two numbers is equal to 120. Then xy must satisfy co-prime concept. Co-prime is the highest common factor of those two numbers is always be the 1. Then see what are the satisfaction. So you can go with the consider for 1 and 120. Next one 260. Next one 340. Next one 430. Next one 524. Next 620. Next 815. And next one 10 and 12. See if you count it as numbers 1, 2, 3, 4, 5, 6, 7, 8. You can choose as 8 as answer, but it is a wrong. Why? Because we need to satisfy xy must be a co-prime numbers concept. Co-prime numbers means 120 is a co-prime, 260 is not a co-prime. Why? Because if it is an even number, definitely it is always divisible number. So 3 and 40 is a co-prime number, 430 is not a co-prime, 525 co-prime, 620 is not a co-prime, 815 is a co-prime, 10 and 12 is not a co-prime. Means if it is a co-prime, we definitely required as a odd numbers. Then see the total number of pairs exist in this question is equal to 4. In the same way, if sum of two numbers is equal to 216, if the HCF is given for 27, same concept. If the numbers are 27x and 27y, sum of two numbers means 27 into x plus y exactly equal to 216. So 27 absolutely for 8 times. Then sum of numbers always required as 8. Then what are the chances? So you can go with a 1 and 7 is a co-prime and 2 6 is not a co-prime. So 2 6 is not a co-prime. Next one 3 5 is the co-prime. Next one 4 is not a co-prime. So there is a 2 chances. So you just replace us here. So 27 into 1, 27, and 27 into 7. So 7 7s are 49, 4 here. 7 2s are 14, 14 plus 4, 18. So 27 and 189. So this is the option. If you substitute as other number also, see 27 into 3, 27 3s are 81. Next one, 27 into 5, 27 5s are 7 5s are 35. 3 here, 5 2s are 10, 135. So 81 and 135 is also answer, but there is no option. See, the numbers always represented 27 and 189. See, if any questions is regarding the HCF, you can assume a number with a x and y. Then whatever the assumption, it need to satisfy the co-prime concept. So the co-prime can indicated as, if consider any 2 numbers, the highest common factor become a 1, means 1 is the only divisible of those 2 numbers. If that pair, we can call as a co-prime number. Next concept, see, find the highest 4-digit number that is exactly divisible by 7. We know the highest 4-digit number means 9999 is the highest 4-digit number. If these number is divisible by 17, if we get 0 as a number, 0 as a remainder, this is absolutely divisible by 17. Check it out whether it is exactly divisible or not. So 17 5s are 85. So we get the remainder 149. Again 17 8s are means 7 8s are 56. 5 here and 8 1s are 8 plus 15 136. Again we left with a remainder 3 1 and 9 again forward. Clear, 139. Again 8 times the again remainder 136. We left with a remainder is 3. If we left with a remainder 3, it means 9999 is not divisible by 17. Here my question. So if you want exact 4-digit number means 9999, we need to subtract these remainder. Don't go with the addition. If it is a addition, it become a 5-digit. But we required only 4-digit number. Then answer 9999 is subtracted as 3. So the answer is 9996 is exactly divisible by 17. Okay, sometimes same question says that find the highest 4-digit number. What number is exactly subtracted? See, what number is subtracted from 4-digit number? 4-digit number, it is exactly divisible by 17. So this is the other form of question. See, if it is a 4-digit number, what we are subtracting? If 3 is subtracted from 4-digit number, the number is exactly divisible by 17. That is also second question. Okay, same question. See, if we go to the other model, find the highest, not so highest, see, I just go to the lowest one. Find the lowest 4-digit number. It is divisible by exactly 15. So that is my question. If any number which is divisible by 15, if you get 0 as a remainder, that is the exact divisible. See, we know the 4-digit lowest number is equal to 1000. Here my question. If it is 1000 is exactly divisible by 15, we get the 0 remainder. Check it out whether we get a 0 remainder or not. So 15 becomes, see, 15 5s are 75 and 15 6s are 90. 15 6s are 90. So we get the remainder 100 minus 90 is equal to 10, again 100. Again 15 6s are 90. We get the resultant is 10. Then see, if these whatever the resultant, we need to add it. Why? Because if you subtract it, it become a 3-digit number. That's why if we want to add the number means 1000 plus the difference between dividend and remainder should be addition. Why? Because there is a common divisor. So common factor for 15 and 10 is equal to 5. Why? Because we get a 5 as a remainder. That's why those difference we should add it. The answer become 1000 plus 5. Value become 1005 is exactly divisible by 15. In the same way, sometimes the question given, what is the number? What is the number is added to the 4-digit number? It is exactly divisible by 15. That is the question. What we are adding here? So 5. So answer become 5. See, if we want the highest 4-digit number, means we can subtract a remainder directly. If we want lowest 4-digit number, means lowest number required the addition of difference between dividend and remainder. The difference we need to add it, and the remainder directly we can subtract it. This is the question related for division of a 4-digit number or lowest number or highest number. So this is the important model. Okay, let's see the question. Find the highest 4-digit number exactly divisible by 12, 15, 18 and 17. First see, if you want to go with a 4-digit number exactly divisible by these numbers, means these all the numbers consisting of a common multiple. The common multiple means we need to find the LCM of 12, 15, 18 and 27. See, if you want a common multiple means focus on the highest number. The highest number can decide that a common multiple of all these numbers. See, 270. So 270 is not divisible by 12. The next number become 540, means the LCM of all these numbers is equal to 540. Then consider as a 4-digit number. 4-digit number means 9999, which is divisible by 540. It is exactly for one time, that is the 540. It's a 9, 5, 4 and again we have a carry forward. And 540 tens are 5400. Definitely it is cancelled on 8 times. See, 540 into 8 times is a 0. 8 4s are 32. 8 5s are 40 and 43. 4, 3, 2, 0. We get a 9 and we are get a 7 and we are get a 279. So 279 is not divisible by 540. See, if you want highest 4-digit number, means the remainder is subtracted from 9999. I clearly mentioned that. If you want highest number means we can subtract it. If you want lowest number means find the difference between dividend and remainder. Those difference always be the addition. Here we can directly subtract it remainder. Then we get a 4-digit number. Then see, 9 minus 9 0, 9 minus 7 2 and 9 minus 2 7. So the answer become 720. So answer 9720 is exactly divisible by 12, 15, 18 and 27. Clear? And this is the introduction about the LCM and HCF. Clear? Thank you.